Okay, ladies and gents, let's check the exercise number 2. During this video session, I'm going to go through all lines of the exercise number 2, giving you the advice how to perform each separate line of the exercise in real time. So this is the exercise which we are conducting together in real time, and you may follow me. Gents and ladies, please open your exercise book at the exercise number 2. This is something what you see at my screen. So exercise number 2, auto position mode, motor vessel Challenger, and we are practicing using the Kongsberg K-Pose software. Let's read the intro part of the exercise. Let's read the intro part of the exercise number 2 and follow me making the pre-setup of equipment before to run the exercise. Purpose. The purpose of this exercise is to use the K-Pose system in auto position mode and to get familiarized with some of the different features available. The built-in trainer in the K-Pose system will be used. In the exercise, there will be references to different procedures. These procedures are written in italic, and you will find them in operator manual, which is available in your personal cabinet and which is downloadable in PDF format if you would like to use it. But I try to do my best, and I try to share my experience and knowledges, and I will make comments on the way for your maximum performance. And after the exercising, even you don't need to read the manual, but if you like, you can do that. Let's make some settings. Start with the system standby mode. Make sure that no position reference systems are enabled. Let's do that. Here is our operator panel. We ensure that the system is on standby. We ensure that control is taken by us. We ensure that there are no position reference equipment input to DP model. Let's check the line number 2 of the settings in proposed exercise scenario. In line number 2, we have a next comment. Select view and submenu reset display units. Click yes to reset the display units to metric units. Now we try to do that. Menu view, reset display units. Yes, we need to reset all display units to metric 1. Line number 3 in settings. Change position presentation to UTM coordinate system with a false easting selected. How to do that? Again, we go to the menu view, we check the position presentation, and here we try to select UTM coordinate system, and in UTM properties we ensure that false easting is selected. We press OK and continue. Line number 4. Set in the settings shown in the table below in accordance with the procedure using the trainer. So you don't need to follow the procedure, we will do it fast together. We need to prepare the starting coordinate, and we need to add to the system the environmental forces. How to do that? We need to open the menu system, and here we have the submenu trainer. In trainer menu we will make all appropriate setup, and before to do that, please I remind you again, check that the DP equipment is staying on standby mode. Otherwise, if you are not on standby, you cannot move to desired position and you cannot make the pre-setup. So, our starting coordinate 1000 meters northing and 500 thousands, 200 easting. UTM zone number 31. Wind speed 10 meters per second, wind direction 330. Sea current 0.5, sea current direction 320, and draft 8.5. So let's check. Wind speed 10 meters we need, direction 330, sea current 0.5, direction 320, and draft is 8.5. Let's apply all of that and OK. We have completed the settings for the exercise number 2, and now we are going to perform the exercise task. Line number 5. Go from standby mode to joystick mode. Select GPS 1 and GPS 2 as position reference system. GPS 1 to be reference of origin. Briefly read through the procedure from joystick mode to auto position mode. Insert alarm limits for position, heading, pitch, roll, and heave in accordance with the settings shown below. So let's make the line number 5. From standby to joystick. We need to select all thrusters. You can press appropriate buttons in thrust group of buttons at the console, or you may open the menu thrusters and you can press the enable all, and in one click you may enable all or disable all thrusters. So thrusters are selected. Let's check the mode. We have to select joystick, and then we connect the GPS 1 with single click. Joystick button we have to press 2 times in 4-second period. This is double click button. But GPS 1 we click only once. Let's add GPS 2 to the system. Pay attention, now reference of origin is GPS number 1. It goes with the asterisk here at the status area of the performance zone. We are on joystick, as in previous exercise. Number 6, briefly read through the procedures from joystick mode to auto position mode and establish the vessel in auto position mode with all thrusters running. Normally we have to select all our sensors. We need to check all of them. All should be online, or at least one is needed. Then thrusters are OK. We fix with double click heading first. Then let's fix sway axis and surge. I fixed in auto position heading first because the mathematical model has a heading priority when distribute the thrust force to the thrusters. That one is important to remember. Insert alarm limits for position, heading, pitch, roll, and heave in accordance with the settings shown below. How to access the alarm limits? Very simple. You may click with pointing hand on deviation plotter, or at performance area you have to access to alarm limits, making the click on deviation plotter. Or you may open the menu auto position and you can find here the alarm limits. We need to make active warnings and alarms, and we need to add some values which you have in line number 7 of your exercise book. So follow me. For position deviation limit 2 meters for warning, 3.5 meters for alarm. For heading 2 meters warning and 3 meters alarm. For VRS pitch, roll, unheave we need to activate, and values are the next one. 2 for the pitch, I mean degrees, for the roll 2 degrees, and for the heave 1 meter. Apply. Let's press OK. Line number 8. Change heading to 403. Use rate of turn 40 degrees. Let's do that. We have change heading button. Let's change heading 043, and the rate of turn should be 40 degrees. Let's apply. System now starts to perform our request. Line number 9. In the keypost system, when you have automatic control of the heading, there are 3 different ways to change the vessel's heading. Explain. Gents, we can control heading next way. When we are in auto position, we can press the button change heading, and we can access to appropriate menu. Or you can click at the heading wheel on the central button, and specific menu appears to control the heading with the rotation of the heading wheel, and decimals are adjusted by those end buttons which we have near the heading wheel. Or one more way to control the heading when you are in auto position is to open the appropriate menu heading through the auto position main menu. Here it is. Or one way more, in status bar area in heading zone, when appears the pointing hand, if you make the left click, you reach automatically to the heading control menu. So quite simple. We know even 4 different ways how to control. Let's answer for the question. There are 3 different ways. Let's answer. We can use change heading button. Heading button at the console. So, or what more? What more? We can use heading wheel central click. Or main menu auto position or auto pose, and there we can find heading line, or status bar, and we can click what? Clicking heading area. This is the answer for your question, and you have to save your answers always. Line number 10. Make a trace of the next movements by the following input. Trace line sampling every 5 seconds and 30 minutes memory. Trend symbols sampling every 2 minutes and 30 minutes memory. I remind you, you have to make a right click on top of the working area when position plotter is selected, and you have to find the view control. In view control you need to open trace, then you have to tick at trace line and trend symbol areas. After that we have sampling 5 seconds for trace line, and we need to keep it in memory 30 30 minutes. For trend symbol we have 2 minutes interval, and we are going to keep it in memory 30 minutes. That's done. Next, line number 11. Change vessel speed, set point to 1.2 meters per second. How to do that? Let's press change position button, go to the menu speed, and here let's enter 1.2 meters per second. Line number 12. Bring the vessel to position 1000 northing, 500 200 easting. How to do that? Change position button, absolute menu, and in that absolute menu let's enter the absolute coordinate 1000 and 500 200. Let's press apply, and she goes there. 9 meters, just 9 meters are missing to arrive in desired position. Then bring the vessel 10 meters to starboard. After arrival in position, which is indicated in line number 12, we are going to bring the vessel 10 meters to starboard. How to do that? We open the change position menu. In increment zone, we are going to add 10 meters, and we are going to show the direction starboard. Starboard. And as soon as vessel arrives in desired position, we will press the apply button to make this step. So let's wait a couple of seconds. Let's perform line 1-3. I'm going to press apply, and now the vessel will go 10 meters to starboard. As soon as we are at starboard, bring the vessel 18 meters in a relative bearing 70 degrees. As soon as we arrive in desired position, we have to follow the instructions which are given in line number 14. Here is written, bring the vessel 18 meters in a relative bearing 70 degrees. Let's open the menu auto position. Here we have position, range and bearing, and here we may add the range and desired bearing, or you can press the change position button at the main console, and you can open the submenu range and bearing, and here you will see more detailed description for this selection. Our expected range 18 meters, and direction was given 70 degrees, which is a relative. So let's select relative. And starting position. For this change we may select the movement from present set point or from the present position. We keep from present set point. So where is the set point? You see. And our change, what we do here, is implemented to this point. We are almost in position. And now, so I am pressing apply, and she is going to proceed 17.9 meters to reach the next set point. In our exercise book, we are at step 1.4. Step 15 or 1.5. Bring the vessel 18 meters to west. How to do that? But let's start from the beginning. Press the button Change Position, open the menu Increment, select the True description of the sides of horizon, add the 18 meters in increment area, and press the button West. And from this set point, which we are going now, we have to proceed here, where you see is our next set point. But I'm not pressing apply yet, because I need to perform the previous step. I remind you, we are going to close the step number 15. We are going to bring the vessel 18 meters to west. So let's press apply and let's close the menu. Now we are going 18 meters to west. As she goes, let's check the line number 16. Bring the vessel 14 meters in true direction 333. We know how to do that. We open the change position area. We want to bring the vessel 14 meters. So direction bearing true, 14 meters in true direction 333. This is our next pre-setup, and let's wait as soon as she finish step which we have added on previous stage. I'm intentionally performing the exercise in a real-time factor that everyone may follow by yourself doing the practical exercises. Finally, almost half a meter to arrive in position. Let's make the step number 16, 14 meters in true direction 333. Apply. Now she goes here, and at the same time we close the menu, and we are going to find out what is expected in line number 17. What is your position? This step we will do later. Number 18. Change rotation center to the 4. To do that, you have to open Auto Position menu, and here we have Rotation Center Information. And in the task we have to select it to 4. So this value is needed. And when we press apply, the center of rotation probably will be moved here. But let's finish our movement first. So 3 meters more. I see it from deviation plotter, which shows me how many meters we need more to proceed to arrive in desired set point. And probably we are going to arrive in some position, and we are going to take the values from this position area available in performance area. So I'm going to answer the question, what is your position? I have almost arrived in position with the difference less half a meter. So let's say this is okay. My position now is 10, 11, point, let's say 3. And here I have 500, 198, and let it be like that. Change rotation center to the 4. Let's try auto position, rotation center, 4, apply. Look, now from this point, all next set points will be implemented. Next question in our exercise book, line 19. What is your position now? Let's write it. 10, 43.6 and 500, 238.9. And you see we have some difference. Next question, line number 20. Why is there a difference between the two positions above? The answer is simple. The DP system shows us the position relative to our rotation center. And as soon as we change the rotation center to the bow, so we shifted it from midship to the bow, the indication in position sector changed due to that shift. Let's write some answer. Because position indicated by DP is relative to actual center of rotation setup, let's say like this. And as usual, I try to press save button. Line number 21. In the simulator, there is an available HPR transponder in the area. Change the reference origin to HPR1. Use HPR1 and GPS2 as position reference systems. Explain how you change a reference of origin. Okay, I need a panel. I'm going to deselect all available position reference equipment. This is first what I do. Then I'm waiting little time before the message position dropout appear in message line. So I acknowledge the previous alarm. And I'm waiting for the position dropout alarm. Now, position dropout alarm appeared. Next, what I'm going to do, I'm selecting the HPR1 as the first. Why? Because the first selected in Kongsberg becomes automatically reference of origin. Look, asterisk appeared. So it means HPR1 is now added to DP system as a reference of origin. Next, I connect the GPS2 and the line number 21 is almost finished. And my short answer, the first selected PRS becomes automatically reference of origin. And the set of actions. Deselect first all PRS. Wait the message to appear. Position dropout. Then select first the desired reference of origin PRS. This short simple answer is enough to cover the question. What is your position in UTM? Okay, let's check. 1043.8 northing and 238.4. Select view and submenu position presentation. Change coordinate system to local northing and easting. Okay, let's make the line 24 and 23. View, position presentation. We have to choose local northing easting and we have to press apply. And the question 24, what is your position right now? My position 38.9 and minus 26.8. Of course, all of that in meters. And the line 25 gives me the question. Explain why the coordinates change that much. The explanation is quite simple. Now we have the presentation of coordinate, which is relative to the HPR beacon from HPR number 1, which became as a reference of origin. And the position presentation now is in Cartesian view, where two axes, northing and easting, are in use. And actually we are 38 meters up from the beacon and 26 meters to left. For that reason we have negative number 26. So that's right, we are here, 26 here and 38 up. So this is how it works. Let's make small explanation. Because now the coordinate is shown in Cartesian way, where reference of origin, the coordinate system, is based acoustic beacon position. Change heading to 348. Use appropriate rate of torque. Heading to 348. We press the button, change heading, and add the value 348. The appropriate rate of turn is about 30-40 degrees. Let's press apply. Now she goes to desired heading, and on the line 27 we have changed the vessel speed set point to 0.8 meters per second. Let's do that. I am opening the menu auto position, speed, and let's add 0.8. I'm pressing apply, and step number 27 is done by me. So let's wait her at heading 348. And after that we continue with the line 28. Now the vessel is at the heading 348 and we are at the stage of line number 26. So we continue our exercise, and as you remember we did already line 27. Change the vessel speed set point to 0.8 meters per second. Let's check. Change position. speed. Yes, we did the line 27 already. Next, line 28. Take the vessel to a position where rotation center 4 is 70 meters south of your HPR beacon number 1 or HPR transporter B01. How to do that? Let's check. This is our beacon number 1. We need to go south of that beacon 70 meters. So how to do that? I try to take my drag and drop position change and I try to put it on top of the HPR beacon number 1. And then I open the menu change position and I try to use 70 meters steps to south, and as you see, it will be implemented to the latest set point what I did. And this is actually our position 70 meters away from the beacon 01. Then I try to press apply and just will keep observing how the vessel goes to desired position with a bow or 4 center of rotation. We need to make 111 meters to arrive here. Concern to drag and drop position change. You need to put the cursor on top of the position set point, and then you need to click on it with a left click, and then you can replace it graphically at any place at the position plotter. And then you have to click again with the left click, and you have to press OK to confirm your position change. Now I'm going to press cancel, and we just keep observing how the vessel moves towards 70 meters away from HPR beacon number 1. And let's check what is the next line in our exercise book. We need to give the coordinate of our position, which is 70 meters away south of beacon 01. Okay, let the vessel to arrive there, and then we will take the coordinate. So next 65 meters are missing, and as soon as we are there, we will take the position from position area. But the system, as you see in line 29, system gives us the local coordinate, just requires the local coordinate. So we will take those numbers without any changes. We are almost in position. The last meter is missing. In couple of seconds, yeah, we are in position. We can take this number minus 74.2. That's what I got, and 1.4, 1 dot or 5. Let it be like that. Next part of the exercise requires us to use the trend view of our DP equipment. Trend can give us the tendency about selected parameter, and it can give it graphically. Let's make a right click in left working area, and let's go to utility. Inside the utility we have the trends menu. Let's open it, Then when you click on graphical area, you have the view control. Then we have to select thruster total force, power buses, and deviation position graphical trends. Let's do that. Thruster total force, power buses, and deviation position. Let's click apply. And let's check the line number 30. There are different trend views available in the DP system. Configure the trend view so that the following trends are shown: thruster total force, power buses, and deviation position. What have the maximum values been the last hour? Thruster total forces and power buses. For the last hour, let's check. We can press here on numeric area, and then we will see maximum, minimum, and average. But the question is for the last hour. Let's select 1 hour for and the maximum thrust force for 1 hour, what we see is somewhere here. 314 is the maximum on that graphic for the last hour. Which unit? Kilonewton. We write it here. 314 kilonewton. And the power buses. For power buses also, let's make the time span as 1 hour. Let's press apply. And let's check in numeric the maximum. The maximum what we have here is 3026 kilowatt. 3026. Deviation position, distance. Okay, let's open deviation position. Adjust it per 1 hour. To open the trend plot setup, I click twice. Or you can go in view control. Add graphical plotter, what you would like to adjust. So, and let's check numerically. The maximum value for deviation position is 111.7 meters. Let's check the next line of the exercise. Line 3.2. Change the rotation point back to center of gravity. How to do that? Probably all of you already remember how to make that. We go in auto position menu, or you can click just directly at status bar in rotation center area, and let's bring it back to midships. Let's apply. Okay, and looks like we completed the stage number 3-4. Next question what we are going to find out and to solve. Number 33. Look at the view thruster main. What is the load on the thrusters now? Resulting force and direction. Okay. With the right click at working area, we go to the thrusters menu and we are looking for the thruster main. Here we have resulting force and direction. And the question is about this force and this direction. So we have 49 kilonewtons, and direction is minus 58.7. Change vessel speed set point to 1.5 meters per second is written in line 36. Okay, let's do that. We go to auto position menu and select the speed. In speed submenu, we add 1.5 as required by line 36 and we press apply. Let's check the next line to perform. Line number 37. Use gain level low and take the vessel 150 meters forward. What is the maximum resulting force during the acceleration, and what is the maximum resulting force during the deceleration? What is the maximum position deviation when stopping at the set point? Okay, let's manage with that task. We have to move 150 meters forward. I press the change position button. I open the menu increment and I have selected the relative way of maneuvering, and I've added the set point to go 150 meters ahead. This is my next set point, and I pressed apply, and I have closed the position menu. And in line 37 I have a preset up for the gain level. It should be low. Let's open auto position and select the gain. Gain must be low, how it is here, and gain level should be low. Yeah, okay. What is the maximum resulting force during the acceleration? Let's open our trends, and here I have this raster total force. Let's select it, and let's take the period for the last 10 minutes, and let's apply. And as you see, here is the maximum when we started the movement, and that was acceleration. And when we about to arrive in position, we will have the deceleration or stopping. Let's wait when the vessel arrives, and probably we will have some peak at the stop. So now we are stopping, I hope. Last 5 meters. And again we have some peak at the diagram, as you see. So let's here to arrive. 10 meters more. I remind you, we are at the stage 37 with the gain level low. We are taking the vessel 150 meters forward, and we are looking for the maximum resulting force during acceleration and during deceleration. And then we have to check out what is the position deviation when stopping at the set point. Last 5 meters. So probably when we started to move, this is our peak. Look at the diagram, and we are retarded. This is our maximum peak of force. So looks like we are almost in position. 2.4, 2.3. Let's check numeric parameters for the total thrust force. The maximum what we had when we started the movement, it was 520. Let's write the parameter here. And the maximum during the deceleration, it was, I try to change the scale, it was about 300 or 295. So the maximum when we did the deceleration, 295. I just changed the view scale of the plotter to take the graphical parameter in my notes. So it was 295 about. So in range, I put it back in auto. That's okay. Next question what we have here is, what is the maximum position deviation when stopping at the set point? Let's check the trend for position deviation. And let's find the numeric. And let's take for the last 10 minutes, or let's say 5 minutes, the setup value for the last 5 minutes, and check numeric. So the maximum deviation for the last 5 minutes on arrival to position, what we see here is a 22 or 20 meters. Line number 38. If you had selected gain level high, what do you think would have happened with the resulting force and the position deviation? This is just a theoretical question, and logically it is simple to answer. If you go to the menu, auto position, and here in gain, if you select gain level high and press apply, then probably the system will make the next reaction. In that setup, resulting force will be higher, but position deviation has to be less. I repeat, the resulting force will be higher, but position deviation will be less. The line 39. Use gain level high and take the vessel 150 meters forward. Let's do that. We go to the menu auto position, we check our gain. It is already high because we have done the pre-setup. And again, we have to move the vessel 100 meters forward. Change position, ahead 150, and press apply. And let the vessel to arrive in position. And again, we will check the parameters and keep them written in our exercise book. So in that exercise, generally we have 53 lines to perform. So we're about to arrive in position. And here we have few picks, if you see. When we started the movement, let's press numeric. Maximum force, what we had, 559. Let's write it here. 559. It is higher, if you see. And when we retarding, it was more than 300, I think 320. Let's write it here. So the values are higher. And position deviation. And in that case, we have what for the last minute? 5 meters, let's say. We have completed the line number 39. But here, guys, during the maneuvering, I paid my attention to the line 33. Line 33, we have missed it, and I recommend you to perform it together right now, because otherwise you will be in troubles when you reach the line number 33. So what is written here? Look at the view thruster main and what is the load on the thrusters now. And here we need to input the resulting force. And I think it was the value of 49 and minus 58.7. That's what we did before. But our mistake is that we have missed the line 33 to add the values, and we have missed to perform the line 34 and the line 35. I think we will do it right now. This is just a small step back, and then we continue with the next steps of the exercise. The line 34 requires to rotate the vessel starboard to the worst thinkable heading in the current weather situation. For us, the worst thinkable heading is when the wind and current are pushing us to any side of the vessel. The exercise requires to rotate to the starboard side. So let's check. Here are our current and wind. The worst thinkable heading probably will be about, I think, 60. Let's adjust our heading graphically like that to 60 about. Let's press apply to 60 about. Let's press OK. And in change heading menu, rate of turn, I recommend you to increase till 60 because I want to finish this step fast. So as soon as the vessel arrives on that heading, in the thrusters main menu, we will check here the forces and we will add them to the line 35. Let's wait. So the vessel almost on desired heading. We did one significant step back in exercising with the reason to close the line 35. The line 35 requires us to give the thruster forces at the worst thinkable heading in the current weather conditions. So we have force 227, resulting force 227, and the direction is changed to minus 91.1. That's our answer for this line. We are stopped at line number 40. Select the view menu and the display unit submenu. Select user definable to and change the user definable to units. Speed to knots, speed wind to knots, speed current to knots. How to do that? Very simple. We go to the menu view and here we are selecting the display units. In display units we are selecting user definable to and we are pressing the details button, and the exercise book requires from us to use speed of wind and speed of current in knots. Speed in knots, speed of wind in knots, speed of current in knots. How to make selection if you have different compared to mine? Just click here in display format area and select the desired unit. After the selection, press the apply button, and now look, your display units now are reflected in knots. Here is written knots current already in knots and wind is in knots. So the operator must know how to change the display units for his operational needs. Line number 41. Change vessel speed set point to 1.5 knot. We go to menu auto position. And here in auto position we have to select the speed. And let's add it to 1.5. Let's press apply. And OK if you want to close the window. Change heading to 006. Okay, it's simple. We go to menu, auto position. Here we have heading 006. Okay, let's press apply. And I try to keep the rate of turn 60 to increase the speed of the exercise. Next, what is expected? 43. Change the alarm limits for heading to 2.5 for warning and 4 degrees for alarm. Okay, also this step we can perform right now when the vessel is on the way to new heading. You can reach to alarm limits just clicking at deviation plotter. And we need to change for heading warning 2.5 and for alarm the setup should be 4 degrees. Let's press OK. That's already done. Next step we will do as soon as the vessel arrives on new heading. I remind you, we are at the step or line number 43. So finally, we arrived at heading 006. And our next step of the exercise is 44. Move the vessel 16 meters to starboard and 26 meters aft in one change of position. How to do that? Quite simple. You know already, let's press the change position button at our panel, and we have to move 16 meters, 16 to starboard and 26 aft, means astern. Let's press OK, and the vessel goes there. And our line 45 requires us to give the coordinate of that position, and also if you see it is local in meters. So in couple of minutes we arrive there and we'll write the result. So we are about to arrive in position and our coordinate is in local position presentation equal to 145 point something and 37 point something. Let's sketch the values. We are going to write at line 45 144 point, let's say 7 and 37.0. Those are our coordinates. Line number 46. Change the reference origin to GPS1. Use GPS1 and HPR1 as position reference systems. Change position presentation from local to geographic coordinate system. Select datum VGS84. Let's do that. We know how to make it. So I'm taking my panel to the visible area. I deselect all available position reference systems and I'm waiting for needed message, position dropout. I try to acknowledge all previous. So now we have position out of limits, position dropout. That one is old alarm. Let's wait for the new one. So this message doesn't appear yet. Let's try to select GPS number 1 as the first one. And in that case, we have it as a reference of origin for our DPI equipment. And let's select as required in line 46 the HPR1 as a second position reference system. We try to select the HiPAP. HiPAP means high precision acoustic positioning system. It's the same. What is HPR? This is a trademark or trade name. So our selection done. Let's check the next step. What is your position, line number 47? But before that, we have to change the coordinate system to geographic coordinate. We go to view, here in position presentation, we try to select the geographic one and we press apply. And okay, of course. And the question is, what is your position? Let's write it. 0, 0, 0, 0, dot 6, 6, 2, 3, 3. And east is 0, 0, 3, 0, 0, dot 1, 2, 2, 6. Change position to a new location. And here we have a coordinate. So make it with DP system. And that one is like the geographical change of position. In exercise 1, I already have shown you the trick with the selection of desired coordinate. Now we will try to change the position using the absolute menu of the change position main menu. So let's open our change position. So let's press the change position button to access the position menu. And we need the submenu absolute. And we are going to use the coordinate provided in the exercise book. 0, 0, 0, 62, 0, 0. Okay. 0, 0, 62, 0, 0, 62, 0, 0. And east is 0, 0, 3, 0, 1500. 0, 0, 3, 0, 0. And here we have 1500. And next subtask here is also and change heading towards the new position. Probably this is about 100. Let's press apply and let's open the heading menu with the change heading button. And here I would like to enter the heading 100. 100, guys. Okay, apply. So the vessel moves towards new position. We are at the line 48 and we are changing the heading towards new position. After arrival in location, deselect the GPS-1 position reference system. So let's wait of arrival to position and then let's deselect the GPS-1 with this button, GPS-1. I'm talking about operators panel. The GPS button is here. So we almost in position And now we are trying to perform the line number 49. After arrival on location, deselect the GPS-1 position reference system. Okay, as I said to you before, let's deselect it with a single click. And the next question, line number 50. Which position reference system provides now the reference of origin? The answer is GPS-1, because we just deselected it, but when we started the exercise, we did already change the reference of origin a few times, and you need to remember that first selected becomes automatically a reference of origin. And if we deselect it, anyway, reference of origin provided by the first selected. To change the reference of origin in Kongsberg, you have to deselect all of PRSs, and then you have to select the desired one. So still GPS-1 as a reference of origin. Next question, line 51. In the gain dialog, select controller mode green. Define out the radius to 40 meters and in radius to 30 meters. Observe what is taking place for some minutes. I remind you that controller gain green or controller mode green, it means that the special mode which is designed for operations with the protection of environments, with the reduction of green gases to atmosphere, or with the reduction of the exhausting gases after internal combustion engines. So here you can adjust the drifting sector, and when the vessel is under controllable drift, then we have the fuel efficiency, fuel economy, because we produce less thrust and we use less fuel and we have less gases to the atmosphere. So green mode is needed solely for that purpose, to protect the environments, and Kongsberg is environment friendly. Line 51. Let's check how to perform it. We go to the menu auto position, and here we have the gain submenu. Then we have to select the green mode for controller, and we have to define outer radius to 40 meters. Outer radius 40 meters. And inner radius to 30 meters. And we have to press apply. And the question is, observe what is taking place for some minutes. Pay attention, those green radius adjusted by you appeared at the screen, and the vessel will drift from inner radius with a use of minimum thrust, then allow it to drift till outer radius, then implement full thrust to come back in the center of the inner radius. And during the period of drifting from inner radius till the border of the outer radius, we have reduction of the gases in the atmosphere, because during that controllable drift period, vessel reduce the fuel consumption and reduce the use of thrust needed to keep the precise position. Here is line number 52. Increase the wind speed to 26 knots in the trainer settings dialog box. Observe what is taking place for some minutes. Okay, let's check. We go to trainer, system, trainer, and here we can change the wind speed to 26 knots. Apply. And let's check what will happen. I see that deviation from position is increased. Look, we have 2.8, 2.9. I hope that everyone can see that we have the drift, and that one is very well visible on the graphical plotter. And now it is 4.5 and so on. As you see, vessel started to drift, and we can wait till the moment when we cross all the radiuses, but I don't want to spend the time for that. You can do it by your own. The result probably will be like that. You will drift out of the outer radius, and the DP system will implement the thrust to bring you back in the pre-adjusted sector. So let's observe. Later, probably the expectation time I will cut from the produced video, because this is just a wasting of time if you want to have the detailed guidelines to be watched fast. As soon as we reach the border of the outer radius with the vessel side, the system started to implement thrust. Pay attention here and here. You see the vectors, all vectors are pushing back the vessel towards starting drift position. And after that, again, the vessel will start to drift. And this is a controlled drift scenario provided by Kongsberg for reduction of exhaust gases to the atmosphere. Let's check the line number 53. Change position 20 meters forward and observe what happens to green controller mode during the movement and when the vessel is in the new position. This is the last step of the exercise, so let's check what will happen. Change position, 20 meters of increment, and it should be forward. And let's press apply and look at the screen. The green controller mode automatically disappear, and the vessel will work in a high precision mode, and the vessel when moves is going to use not a green presetup. It will use a high precision, or she will go with a high precision. But the question is, what will happen with the green controller when the vessel is in new position? Let's check, but looking forward, I may say you that as soon as vessel arrives to the new position and stabilize, then she will operate again in green controller mode. But as soon as operator gives the new command to go, the vessel is automatically starts to use the high controller mode preset up. That's how it is. So let's observe those last 20 meters to go and to see what happened. And what we have, again, the green controller setup is available and in force and is visible graphically at the position plotter of your DP software. So at this stage we might finish the exercise number 2. I'm happy to present you that exercise in the real time, let's say. And as you see, Next, what is expected is exercise number 3 connected with auto track mode. Thanks for your kind attention and good luck!